Good morning. Welcome back. Hope you had a nice weekend and you've done well in your tests. Last class we did searching. We started with searching. We did what do you mean by searching? What exactly is that? And what are the different searching techniques you're going to do? And we did linear search. We did with an example, the algorithm, as well as the program. I showed you the execution of it also. So searching is nothing but finding out whether an element is present in the list or not. I'm not worried about how many times it is repeated here. I'm just checking whether it is there or not. For example, the list contains the same element, like all the 10 elements are same, and I'm searching for that element only. Then also, when I find the occurrence of it, when I encounter it first time, I stop there because my job is to say whether it is there in the list or not like how many times and where it is located. So getting it, searching is nothing but you just have to find whether the element is there in the list or not. In linear search, it was an unsorted list. So, what do you mean by unsorted? That is, the list was not arranged in ascending or descending order. It was a unsorted list. So, I'm not the user enters the way the user enters, you are going to use the same list. You're not going to place it in any order, right? So that is linear search. But then in binary search, it has to be a sorted list only. That is, you cannot apply binary search algorithm to search for an element in an array if the list is unsorted. You can apply it only on a sorted list. The list can be either placed in ascending order or descending order, but it has to be a sorted list only. So, binary search, that is one of the major differences between linear search and binary search. In binary search, the sort elements of the list has to be placed in an order. It can be either ascending or descending order. Please make a note of it because you cannot apply binary search on an unsorted list. For all my examples, I will be taking that the list is placed in ascending order. That is, the elements in the list are placed in ascending order, that is starting from the least to the highest. Fine. So let me write one example in which I will take three cases and I will show you the same example with three different cases where the element is in the right side of the list, where the element is in the left part of the list, and the element not found. Okay, so let me start with that. Binary search, sorted list only. So the list has to be sorted only, right? Without it cannot be performed on an unsorted list. A be an array of n elements. Let A be an array of n elements. Then n is the number of elements in the array. So let n be the ELE search element. Let ELE be the search element and LOC is the location of the search element. Location is nothing but the index value of the search element. Getting it? Location is nothing but the index value of the search element. Let LOC be the location of the search element. After that, what am I going to do? LOC location, then low is the index of the first element. Okay. High is the index value of the last element. Getting it? See here, to perform binary search, the array has to be sorted only. That is, it has to be placed. The elements of the array has to be arranged in either ascending order or descending order. In all my examples, I would be taking it in ascending order. So what is A here? A is an array of n elements where n is the number of elements in the array. ELE is the search element, that is the element for which I am searching in the array A, whether it is present or not. If the element is present, what is the index value of it? That is, location is nothing but the index value of that element in the array. If the element is present in the list, low is a variable which holds the index value of the first element in the list. High is the index value of the last element in the list. So these are the different terms I would be using both in my algorithm as well as program. So the same terminologies we will take into consideration when I write my example also. So please make a note here. A is an array of n elements. N is the number of elements in the array. ELE is the element for which I am searching for, that is searching whether the element is present in the list or not. And then LOC is the location of the search element. If the element is found, what would be the location of it? Location is nothing but the index value of that element. And then low is another variable which holds the index value of the first element in the list. And high is the index value of the last element in the list. Please make a note here. Now we'll continue with our example. Okay. So now what will I do here? You are now familiar with the terminologies. Let me continue ahead. For example, let my array A be so let it be 22, 24, 26, 28 and 30. These are the elements of my list. So this would be stored in 0th position. Yes. The next would be stored in this is the index value. So the index value of the elements. The elements of my list are 22, 24, 26, 28 and 30. These are the elements in my list. You can see that they are arranged in ascending order. So 22 is in A of 0th position, 24 is in A of 1, 26 is in A of 2 position and 28 is in A of 3 position and 30 is in A of 4 position. Getting it? So the total number of elements here, what is the n value? N is nothing but 5. You can see from here also 5 elements. 0 to n minus 1, that is 0 to 4 is nothing but 5 elements. Correct? And what is low here? Low is the index value of the first element in the list. Correct? Which is the first element here? 22. From the example you can see 22 is the first element. So what is the index value of 22 here? Index value of 22 is nothing but 0. You can see there. Okay. What is high then? High is the index value of the last element in the list. So here, which is the last element? Excuse me. Which is the last element here? The last element is 30. So what is the index value of 30 here? 4. So high is nothing but 4, which is the index value of the last element in the list. Correct? Now I have to LOC is equal to -1, assuming element not present in the list. Correct? I am assuming that the element is not present to begin with. LOC is -1. If the element is found, then I will say LOC is equal to index value of that element. Okay. To begin with, I will say LOC is -1 because the array subscript starts from 0. So if it is 0, it means that it is the first element. For that reason, I will make LOC is equal to -1, assuming that the element is not present in the list to begin with. Now, for example, the search element, that is, the element I am searching for is 28. Please make a note here. See, the element I am searching for is 28, and to begin with I will say LOC is equal to -1, assuming that the element not present in the list. N is the total number of elements in the list. You can see it is 5 elements. The elements are 22, 24, 26, 28 and 30, which are arranged in ascending order. Low is 0 because low is the index value of the first element in the list. The first element is 22. The index value is 0. High is the index value of the last element in the list. The last element is 30. The index value is 4. And for example, as a user, I am searching for an element 28, whether the element is present there in the list or not. So, ELE is equal to 28. So, we are clear what are the different terms and what has what value to begin with. Please have a look here. If you have any doubts, just post me. I'll let you know. I'll clear your doubts. After that, what you need to do is, this is the procedure. First, you need to make a note of what are the things asked, what are the values it holds, what you have. The procedure is, you need to find the mid value. So, what is mid? Mid is nothing but low plus high by 2. Okay, mid is nothing but low plus high by 2. Here I am going to do integer division. That is, if any point value is there, I am just leaving it. I am going to only take the integral part of it. Fine. So what would be mid? Is nothing but, what was the low value here? It is 0 plus high is 4, right? By 2 is nothing but 2. Correct? So what is mid value? Mid value is 2. Compare the search element with A of mid. compare the search element with A of mid. See, A of mid is different than mid. Mid is only the index value. A of that index will be the element which is present in that location. When you are writing also, you have to be careful. The difference between A of mid and mid. Mid is just one number. How you are getting it? Low plus high by 2. Whereas A of mid, that is A of 2, is the element which is present there. So compare the search element with A of mid. What was the search element? Yeah. See here, what is the search element? ELE is equal to 28. What is A of mid? Mid is 2. So A of 2. What is A of 2 here? The A of 2 is nothing but 26. Right? Here A of 2. Because mid is 2 here, I am finding it. So compare search element with A of 2. So A of mid is nothing but A of 2. What is A of 2 here? 26. And what is search element? 28. So I need to compare. A of search element is 28 and 26 because A of mid is 26. So not equal. Correct? Hopefully you have understood till here. After that, see whether the search element is greater than the A or mid element or less than the mid element. So compare, see whether the search element is greater than the A of mid or less than A of mid. So you need to first you compare it, and now what am I going to do? I am checking because they are not equal. 28 is not equal to 26, correct? So now what am I going to do? I am going to check if the search element is greater than A of mid or less than A of mid. So 28 is greater than 26. Yes or no? Yes. So what you can from this you can see, since it is a sorted list, yeah, it is arranged in an order. 28 is greater than 26, then it can be in the right side of the list only. You cannot find the element in the left side of the list, correct? Because the search element is greater than the A of mid element. So what you can do is if the search element is greater than the mid element, you have to make low is equal to mid plus 1 and high remains as it is, because this element can be there only in this part of the list. It cannot be there before the mid element. It has to be there after the mid element only, because the array is arranged in a order. So what am I going to do here? Then I will make, since search element is greater than A of mid, low is equal to mid plus 1. So low is equal to, what is mid? 2, correct? Plus 1, which is 3. Now again find the mid value. What is mid? Mid is nothing but low plus high by 2, which is equal to, what is low value? It is 3 here. So 3 plus 3 plus, what is high? High was 4, because whatever, I haven't changed the high value. So if I have not changed the high value remains the same. Where is it? See here, high is the index value of the last element. High is 4. You can see it here. I have not changed the high value. I changed only the mid value. So it will remain as it is. That is 4 by 2, which is nothing but 7 by 2 is what? 2, 3 times 6 and point and then 5. But since it is integer division, I will not take the point value. I will only take the integral part of it. So it becomes 3. Because it gives you 3.5, I will take only the integer part. I will not be taking the fraction part, which is 3. So now you got the mid value, which is 3. Compare search element, search with A of mid, correct? So what was the search element? 28. And what is A of mid? Mid is 3. So we will see in the array what is A of 3. What is A of 3 here? See here, mid is 3, right? A of 3. What is A of mid? A of 3 is 28. In the array, you can see it there. So I'll come 28 and 28. Correct? How did I get that? Because I compared 28 was the search element, A of mid is nothing but A of 3, and at A of 3 location we found 28. So matches. When it matches, what is the LOC? LOC is equal to mid is equal to 3. So since LOC is greater than -1, element found in location 3. So this is how you find it. We'll go through this again. Okay, let me go through this again, then I will write one more example. That is why binary search has a sorted list only. Yes, it has to be a sorted list only. An array of n elements, where n is the number of elements in the array. ELE is the search element. LOC is the location of the search element. Low is to begin with. Low is equal to the index value of the first element. High is the index value of the last element. And suppose this is my array 22, 24, 26, 28 and 30. So the locations of it is A of 0, A of 1, 2, 3 and 4. And you can see that it is arranged in ascending order. 0 to 4 is nothing but 5 elements. The n value is 5. To begin with, low is the index value of the first element. Here the first element is 22. So the index value of the first element is 0. Low is 0. High is the index value of the last element. The last element is 30. The index value of 30 is equal to 4. So the high value becomes 4. To begin with, I will say LOC is equal to minus 1 because I am assuming the element is not there in the list. So if it is there, then I will change the LOC value to the index value of the element. After that, ELE as a user, suppose I am searching for an element 28 in the list. So the search element here is 28. Then the procedure begins. I need to find the mid value. First, I need to, in binary search, you need to find the mid value. And whenever I'm finding mid, it is integer division. Even if it divides to a point value, you will leave the point part, only take the integral part of it, that is mid is equal to low plus high by 2. What was low? It was 0. High is 4. So 4 by 2 is nothing but 2. Compare the search element with A of mid, that is 28 and 26. How did I get that 28? I have entered as a user because I am searching for an element 28, and 26, what is mid is 2. So A of 2 in the list, A of 2 is what? 26, correct? So I am searching for that. So 28 and 26 are not equal, correct? Now, when they are not equal, you have to see whether the search element is greater than the value present at the mid element, that is greater than A of mid or less than A of mid, because based on this you will search the split the array and search the other part, because since it is arranged in an order, it cannot be present in both the sides of the A of mid. Yes, if so, what happens if the search element is greater than A of mid value? You have to make low is equal to mid plus 1 and high remains as it is. Since the search element is greater than A of mid, because 28 is greater than 26, I am going to make low is equal to mid plus 1. Low is equal to 2 plus 1, which is 3, because mid was 2, right? It is not A of mid here I am talking. I am only talking about mid. You have to pay attention when I say A of mid and when I say mid. So mid again is equal to low plus high by 2. So what was low? It is 3 because I have changed it to 3, and high I have not changed it to any value. So it remains as it is. So it was 4 in the beginning. It remains as it is. So 3 plus 4 by 2 is 3.5. Since I am doing integer division, I will leave the point values. I will take only the integral part of it. So it becomes 3. Now the same procedure. Compare the search element with A of mid. So search element is 28 and A of what is mid value here? 3, right? So I need to compare it with the A of mid, nothing but A of 3. So A of 3 is 28 here. You can see in the list. So I will say matches, right? And that is why LOC will take the mid value, which is equal to 3. Since LOC is greater than minus 1, because I found the element found in the location 3. Hopefully you've understood this. Please go through this again, then we will continue. I will write for an element which is lesser than the mid element, because now we wrote the example for an element greater than the mid element. Now let me write search for an element which is lesser than the mid element. Now we will start with a different search element wherein the element is lesser than the mid value. Like we found 28 is greater than the mid A of mid to begin with. Now let me search for 22 to which is lesser than the mid value. So suppose this is an array. Okay. 22, 24, 26, 28 and 30. They are placed in ascending order and the subscript values you have found. So what is n? N is 5. Yeah. That is the number of elements. Suppose if the search element, that is as a user, I want to search for 22 in this list, whether it is present or not by applying binary search algorithm. Okay. So what will be the value of LOC? LOC would be -1 to begin with because I assume that the element is not present in the list. Fine. After that, what is the low value? Low is nothing but the index value of the first element in the list to begin with, that is 0. What is high? High is nothing but the index value of the last element in the list. The last element is 30. So what is the index value of it? Index value of it is 4. Now, according to my procedure, I need to find the mid value. So, mid is nothing but low plus high by 2, right? Low plus high by 2, correct? So, how will I do that? Low plus high by 2 is nothing but mid is equal to, the low value is 0 plus high is 4 by 2, which is nothing but 2. So mid value is 2. Compare search element with A of mid, not directly mid. Here I have to compare it with A of mid. So what was the search element? 22. And what is A of mid? What is mid? 2. A of 2. So what is A of 2 in the list? 26. Correct? So I will compare 22 and 26. So do not match. They are not equal. Now what I have to do? I have to check whether the search element is greater than the mid A of mid or less than the A of mid. CHACK, check if the search element is greater than A of mid or less than A of mid. So what was search element? 22. And 22 and 26, definitely the search element is less than A of mid. You can see here 22 is less than 26. What is A of mid? 26. Since search element is less than A of mid, it can be there in the before of mid value, right? High is equal to mid minus 1. Getting it? Last example, it was greater than. When the search element is greater than A of mid, low becomes mid plus 1 and high remains as it is. When the search element is less than A of mid, high is equal to mid minus 1 and low remains as it is. Please make a note of this. Okay, so what is high? Well, high is equal to what is mid? 2, right? 2. I am not talking about A of mid here. I am talking about only mid. And mid was 2. I calculated it here. A of mid is different than mid. Mid I calculated here, which was 2. A of mid is nothing but A of 2, that element. Mid is just the value. So mid is 2 here. I'm making high is equal to mid minus 1, that is 2 minus 1, which is 1. Clear? Now find the mid value. Mid is equal to low plus high by 2, which is nothing but 0 plus 1, 0 plus 1 by 2, which is 0. That is 1 by 2 is 0.5. I will leave the fraction part. I take only the integer part because this is integer division. So I got 0. So what is the value of mid? Mid is 0 because I will not be taking the fraction part. I take only the integer part here, that is 0 plus 1 by 2 is nothing but 0.5. Since it is integer division, I will be taking only the integer part of it, not the fraction. So it becomes 0. What is the value of mid? Is 0. Now what I have to do? Compare the search element with A of mid, correct? So what is search element? Search element is nothing but 22 because I have entered, and A of mid. What is mid here? 0. So A of 0, correct? I have to compare it with A of 0. So in the list, what is A of 0 here? A of 0 is 22. You can see here in the array. So 22 and 22. So matches. Okay. So what will LOC become? LOC is equal to mid, which is equal to what? 0. That is, since LOC is greater than minus 1, element found in location 0. Yeah. So this is the example wherein the element is less than the element present in the location of mid. That is, when the search element is less than A of mid, you will change high to mid minus 1. When the search element is greater than A of mid, you will change the low value to mid plus 1 because it is a sorted list. It cannot be on the both the sides of the list. Getting it? So we did examples wherein it is the search element is less than the A of mid value and where the search element is greater than A of mid value. Please go through this again. Hopefully you have understood. Think. If not, because we'll continue with when the element is not present in the list. So for that you should know for any algorithm when to stop. Like you should stop at some point. So you're going to stop when low becomes greater than high. Okay? Low is greater than, not equal to, because when low is equal to high, still one element is present. So when low is greater than high, stop searching when low, like you will exit from searching, or you will stop searching when low value, that is not A of low, I am talking about only low. Low becomes greater than high. You will stop searching. Okay. Let me write the same array here. What was that? 22, 24, 26, 28, 30. So this would be A of 0, A of 1, A of 2, A of 3, then this is A of 4. You can have a look. This is there. Please make a note of all this, then only you can understand. Otherwise, you will once you don't understand the procedure, you will not understand the algorithm, or you will not be able to write the program for it. Okay? Then 22, how many n value is equal to 5, because the total number of elements is 5 here. For LOC is equal to minus 1. To begin with, I will assume the element is not present in the list. And when do I stop searching? When low becomes greater than high, I need to stop searching. Okay? Now what I will do, this is correct. Yeah, LOC is equal to minus 1. Then, for example, ELE is equal to, I'll say, 0. I'm searching for an element. Okay, let it not be 0. Like I'm searching for an element 10 in the list. To begin with, what will be the low value? Low is equal to the index value of the first element in the list, that is 0. High is equal to the index value of the last element in the list, nothing but 4. Please make a note of this, then we'll continue. Now we'll continue, okay? Because you have made a note of this. What is the search element? Search element is 10. Low to begin with is the index value of the first element in the list, that is 0. High is the index value of the last element in the list, that is 4. Now we will continue with that. The procedure is I need to find the mid value, which is nothing but low plus high by 2. Low plus high by 2, which is nothing but mid is equal to 0 plus 4 by 2. Okay? Which is mid is equal to 2. Compare search element with what you are going to compare the search element with A of mid. You're not directly comparing it with mid. If I say mid, then it is 2. A of mid is different than mid. Please, you have to pay attention here. And while writing the algorithm or the procedure also a program, you have to be very careful when to use A of mid and when to use mid. Compare search element. So what was the search element? 10. I had entered 10 and A of 2. So what is A of 2 here? A of 2 is 26. So I will say A of 2. So do not match. They do not match. So what am I going to do here? Compare. It's a check. If the search element is greater than A of mid or less than A of mid. Okay. So what am I doing here? I'm comparing whether the search element is greater than A of mid or less than A of mid. I need to do since search element is less than A of mid, right? Because 10 is less than 26. It's less than A of mid. What am I going to do? I'm going to make high is equal to mid minus 1. That also we understood. When search element is greater than I have to make low is equal to mid plus 1. If the search element is less than A of mid, I have to make high is equal to mid minus 1, which is nothing but 2 minus 1 is equal to 1. So what is the high value? 1. So now let me find mid is equal to what is mid here? Low plus high by 2. That is mid is equal to 0 plus 4 by 2. Sorry, not 4 here. What is mid here? Mid is 1, right? Sorry, high is 1. So 0 plus 1 by 2, which is equal to 0. Because I am taking integer division, 1 by 2 is nothing but 0.5, which is 0. Now compare search with A of mid. So 10 and what is A of mid? Mid is 0 here. So what is the A of 0 value here in the list? 22. Do not match. So check since search element is less than A of mid, high is equal to mid minus 1, which is nothing but 0 minus 1, which is minus 1. 0 minus 1 is minus 1, correct? Yeah. So, but what is that? Low is 0 and high is minus 1. But low is greater than high because 0 is greater than minus 1. Since low is greater than high, that is 0 greater than minus 1. Stop searching. LOC is equal to minus 1. Since LOC is minus 1, since LOC is minus 1, element not found. Okay, we'll just go through this again. See here, we'll start from the lowest case to the highest. Okay, what is here? I am saying the elements of the list are 22, 24, 26, 28 and 30. They are in the location A of 0, A of 1, A of 2, A of 3 and A of 4. The number of elements is 5. LOC is minus 1 because to begin with I will say the element is not present in the list. ELE is 10. Low is 0 because low is the index value of the first element in the list. The first element is 22. And when do we start searching? When low value becomes greater than high. This is not greater than equal to here. It's only greater than high. I will stop searching. Then high is 4. Yes. Mid is equal to, why is high 4? Because high is the index value of the last element of the list. So high is 4. Mid is equal to low plus high by 2. Mid is 0 plus 4 by 2. That is 2. Compare the search element with mid element. Search element was 10. I had entered 10. And mid element is A of 2 was 26 over there. You can see A of 2 is 26. So do not match. Then what I have to do? I have to check whether the search element is greater than A of mid or lesser than A of mid. Depending on that, I will change the high and the low value. Since it is search element is less than A of mid, what I am going to do? I am going to change the high value, which is nothing but mid minus 1, which is 1. That is 2 minus 1. Again, I am going to find the mid value. Low remains as it is. That is 0 plus high is 1 by 2. That is mid is 0. Now compare the search element with A of mid. Search element is 10 and A of mid, that is A of 0 is 22 in the array, right? A of 0 is 22 here. So I am going to compare 10 and 22. They do not match. And since 10 is less than A of mid, again I have to change high value. What is high? Mid minus 1. So it becomes minus 1. 0 minus 1 is minus 1. And what is the low value? Is 0. Since low is greater than high, stop searching and element not found. Hopefully you have understood the procedure of binary search. Please go through your notes, what you have noted down for all the three examples. So you would have understood the procedure. This is nothing but trace of the algorithm which can be asked in the exam. When asked, you need to write it in this way only. So now please note down homework question. Apply binary search. Apply binary search for the following sequence of numbers. That is 11, 22, 33, 44, 55, 66. Search element 89. So, homework question is apply binary search for the following sequence of numbers 11, 22, 33, 44, 55 and 66. Search element is 89. You need to write the proper trace of it. So please go through this. In tomorrow's class, we'll start with the algorithm, then the program, which also happens to be your lab program, and then I will show you the execution of it. Stay safe, take care, bye bye.